In exercise 14E, we're going to see a formula for finding an angle between two lines. I could just give you the formula and say this is the formula. It's not on the formula sheet. You can almost get it from something else that's on the formula sheet and leave it at that. And you can see the actual formula. It is in the format that tan theta is actually equal to 1 gradient, m stands for a gradient, minus the gradient of the other line, over 1 plus the product of the gradients of the two lines. Remember, we're getting a formula for finding the angle, so we would be finding theta. So ultimately we'd have what theta is actually tan inverse of whatever this calculation is. And this is just based on the gradients. 1 plus m1, m2. Now, I think that if that's all I did, then you are missing a lot of what I often talk about, which is that the maths is all connected. So if at any time you feel like you're losing what the purpose of this introduction is, then think back to this that I'm saying. Really, this is all about you being aware there's a formula for finding the angle between two straight lines with gradient, or they could be curves. Gradient of one of the lines, we will just call m1 for the convenience. m2 is the gradient of the other, and we just use this equation. There's going to be, I'm going to refer to a lot of angles, but keep in mind theta is the actual angle between the two lines. And you can see this here, say for example line 1, line 2, and theta is the angle between those two lines. We know that the angle opposite is equal from a geometry property, opposite angles. Vertically opposite angles are equal. We know that this one would be called 180 minus theta, or pi minus theta in radians. And again, those two are equal. So just trying to make sense of this diagram. We've got our two straight lines, a formula to find the size of that angle there. Theta is, as I showed you below. However, I'm not going to just leave it at that, because there's a lot of nice connections that I think it's really worth looking at. And the reason is because we've got the connection, and I've said here the connection of 3 mathematical concepts. So one concept is the angle between the two lines. We actually get a formula for that. Another thing that we need to connect to is this idea that the gradient of a line is tan of, now this is not theta, this is not theta, this is alpha. This is, remember back in the preliminary course, we found that the gradient was tan of the angle that the line makes with the positive x-axis. So that's a property you learnt back in the prelim trig chapters. So here are two concepts, angle between two lines, somehow connecting to the gradient that the line makes with the positive x-axis, and these new identities that we've learned about tan of one angle minus the other. So if you need to pause the video at even now and go back and look at what that identity is, tan of alpha minus beta, keep in mind it's not on the formula sheet. The one on the formula sheet is tan of alpha plus beta, but all you need to do is swap the pluses and the minuses, and you can get the equivalent. So we've got this concept of an expansion for the tan of the difference between two angles. We've got this concept where gradient of a line is tan at the angle that the line makes with the positive x-axis. And we've got a formula coming out of all of this which enables us to get the angle between two lines. And then I guess there is just one more thing that you need to remember when we get to it, and that is that if I consider this little triangle with theta here and beta there, oops, that should be just nice. This angle in here, if this one out here is alpha, this one in here is 180 minus the alpha, then you're going to see me write that theta plus beta plus 180 minus alpha, three angles in a triangle, add to 180 degrees. So you know that concept as well. Okay, let's get started to see how you come up with this property about the angle, or it's not a property, it's a formula for finding the angle between two straight lines. I've already touched on this, that we saw that if M1 is the gradient, say line 1, makes with the x-axis, then tan of alpha is the gradient. So we've got line 1, we've got line 1 here, and I've called the angle that it makes with the positive x-axis alpha. You can see I've got line 2, and the angle that it makes with the positive x-axis is beta, alpha and beta. Now, theta is the one that we're eventually getting to. At the moment, we've got alpha and beta. So, we know that just by definition, and that we learnt this association from the previous exercise, that the tan of alpha minus beta is tan alpha minus tan beta over 1 plus tan alpha tan beta. And we're going to combine that with the angle sum of a triangle, where you can see over here, you know now where the theta plus beta plus 180 minus alpha equals 180. You know where this line now hopefully comes from, angle sum of a triangle. Doing a bit of tidying, we would have theta plus beta is equal to 180 minus 180 plus alpha, and 180 minus 180, and we want an expression for theta, and it works that theta is alpha minus beta. Now, theta is alpha minus beta. We have this expression for alpha minus beta, but so we could actually say this expression is actually the tan of theta as well. And so that's what happens. So we get the tan of theta, and theta can be replaced with alpha minus beta in this case. Then by definition of these compound angles, the tan of one angle minus another is tan of alpha minus tan of beta over 1 plus tan alpha tan beta. However, from this diagram, the tan of alpha is the gradient of the line 1. Tan of beta is gradient of line 2, 1 plus the product of the gradients. And like I've said, to find theta, you take the tan inverse of this calculation. I think that's very sweet. So like I said before, I could have just straight out just given you this formula, this one down here in fact, and said learn it. You could pick up how to write that from what's on the reference sheet, and I think that's sort of cheating you in a way, because there's a lot of logical connections to make there, which, who knows, it could help you out in a problem somewhere at some time. Now, just one more thing. We don't quite stop there because we know also from a trig identity that tan of 90 minus theta is minus tan of theta. Now, you may have done that maybe in junior school. And again, that's a little bit like the sine of 90 minus theta is cos theta. It's one of those. So we can see that tan of theta and tan of minus 90 minus theta only differ in sign. So the tan of theta is the absolute value. We just consider the absolute value of our ratio or tan of our ratio, and then we substitute the gradients and we get the tan of theta is actually the absolute value of that, or theta is tan inverse the absolute value of that. So that's the formula to learn. It's not on the formula sheet, but knowing the variation of tan alpha plus beta is, and this setup, then you can make the adjustment to the minus the angles and adjust this ratio, put the minus in there and the plus there, and then knowing that if alpha is the angle the line makes with the x-axis, you can replace it with the gradient of the line. That's really nice on straight lines. Gradient of straight lines, very easy to get. Very easy to put the values in here. They're the gradients of the lines. This will also work when we go to curves, not straight lines, and to get the gradient at any point, of course, we would be differentiating. I'll stop the video there and do the examples in another video.